Hello everyone, this is Mogradi and you're watching EPC Electrophysics classes, and today I'm going to discuss one of very interesting topic of class 7 science, chemical substance and processes. Clear? Basically, you are already aware about the chemical substances like matter, molecules, atoms, substances, elements, compounds, solid, liquid, and gas. So here we will discuss about the properties of that atoms and molecules. So let's start. So as you know, matter exists in three states: solid, liquids, and gas. Matters, as you know, matter exist in three states: solid, liquid, and gases. Solid, liquid, and gases. Clear? And all matter is made up of small particles called atoms. Matter is made up of small particles called atoms, and these atoms combines to form molecules. Clear? And the materials which are made up of same kind of particles that has same atoms or same molecules are called pure substances. Clear? So basically pure substances can be further classified as elements, or you can say compound. Further classified into elements and compound. Clear? So element is a pure substance. Element is a pure substance which is made up of atom of same kind. It is made up of atom of same kind. Clear? For example, iron. Fe is an element which is made up of iron atoms. Clear? Iron atoms. And the compound is a pure substance which is made up of molecules of the same kind. It is made up of molecules of the same kind. Molecules of same kind. And a molecule of a compound consists of atoms of two or more different elements that have combined in a fixed ratio. Clear? So what? Like water is a compound and made up of water molecules, and each molecules of water contains two atoms of hydrogen and one atom of oxygen. Clear? One more thing is that mixture. If we talk about mixture, so a mixture contains two or more or more substance. Two or more substance, clear, mixed in any proportion, mixed in any proportion, mixed in any proportion. The component of mixture are not chemically combined with each other, clear. So mixture is therefore not a pure substance. Mixture is not a pure substance. Mixture is not a pure substance. Next topic is chemical symbols. Chemical symbols. So chemical substances are often represented by symbols. However, the symbols are different elements are now represented by the letter of the English alphabet. So here I am writing some elements and also their symbol, like hydrogen, sodium, magnesium, aluminium, calcium, potassium, iron, copper, gold, and means AU, argentinum, silver, Ag, carbon, oxygen, sulfur, nitrogen, phosphorus, chlorine, bromine, and iodine. Clear? Now it is enough. So if we talk about chemical formula, means application of these chemical symbol is chemical formula. So chemical formula of a substance is based on the composition of that substances. Chemical formula of a substance is based on the composition of that substances, and it indicates the type and number of atoms of each kind present in that substance. Clear? For example, as we know, chemical formula of water is H2O. This means that a water molecules is formed by combination of two atoms of hydrogen and one atom of oxygen. Similarly, the formula of carbon dioxide means CO2. This means that a carbon dioxide molecule is formed by the combination of one atom of carbon and two atoms of oxygen. Now the question is how to write the chemical formula, means how to write chemical formula. How to write chemical formula? So to write the chemical formula of substance, the chemical symbols of all the elements are written and the number of atoms of each element is written as a subscript to the right side of its symbol. For example, nitric acid, contains one atom of hydrogen, one atom of nitrogen, and three atoms of oxygen. So the chemical formula of nitric acid is HNO3. Clear? So one is not written as a subscript. Clear? So similarly, glucose contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atom of oxygen. So its chemical formula is C6H12O6. So many substances are made up of positively and negatively charged particles known as ions. Clear? So let us learn to write the chemical formula of such substances. So for this we need to know the symbol and the charge of different ions present in given substances. Clear? Like sodium. Like sodium, Na plus, magnesium, Mg2 plus, aluminium triple plus, calcium, Ca2 plus, hydrogen, H plus, copper, Cu double plus, iron, Fe2 plus, zinc 2 plus, and ammonium NH4 plus. Clear? These are the positive ions. If we talk about chlorides, means Cl minus, oxide O2 minus, hydroxide OH minus, carbonate CO3 double minus, sulfate SO4 double minus, nitrate NO3 1 minus, acetate CH3C double O minus, phosphate PO3, or you can say PO4 3 minus. Clear? So in the name of chemical substance made up of positive and negative ions, generally the name of the positive ion is mentioned first, followed by the name of the negative ion. For example, the chemical name of common salt is sodium chloride, NaCl. Here the name of the positive ion means Na plus mentioned first, and the name of the negative ions means Cl minus chloride ions is mentioned after this positive Na plus. So in the chemical formula also, the symbol for the positive ion is written first, followed by the symbol for the negative ion. Clear? Hence the chemical formula of sodium chloride is written as NaCl. It is not written as ClNa. Clear? This is wrong. Okay, so if we summarize the procedure, so we can say like point wise, symbols of positive and negative ions are written and their charge is written on the top right corner. Top right corner. Top right corner of the symbol. So common factor means second point is common factor if any is removed. Common factor if any is removed. Remove from what? Remove from the numbers in the charges of the two ions. And the third point is the charges of two ions are crisscrossed, means these numbers are now written at the bottom right of the symbol of the two ions. This gives us the chemical formula of the substance. So let us take some examples to understand this. Okay, so if we talk about the example like Na2O, sodium oxide. So here Na plus and O2 minus, sodium oxide. Oxide means O2 minus, sodium Na plus. So to write the formula of sodium oxide, we write the symbol for sodium and oxide ions along with their charges. Clear? So there is no common factor in the numbers corresponding to their charges. We now crisscross their charges. Crisscross their charges. Therefore, Na2 means 2 is here and O with 1. So we ignore 1, then we obtain Na2O. So hence the chemical formula of sodium oxide is Na2O. So we can say that the subscript is not written as a chemical formula, means subscript 1, basically subscript 1 is not written as the chemical formula. So let's take one more example, like to write the formula of aluminium sulfate. So we first write the symbol of aluminium, Al3 plus, and sulfate ions SO4 double minus, or you can say 2 minus. Clear? So there is no common factor in the numbers corresponding to their charges. So we now crisscross their charges and write the crisscross number as subscripts against two symbols. Okay, so Al2 minus means Al2 and SO4 whole 3 plus, therefore Al2SO4 whole thrice. Hence the chemical formula of aluminium sulfate is Al2SO4 whole thrice. Al2SO4 whole thrice. Clear? Now let's take one more example. So to write the chemical formula of calcium carbonate, we first write the symbol of calcium and carbonate ions. Calcium means Ca2 plus, carbonate ions CO3 2 minus. Here the common factor between the numbers corresponding the two charges is 2. 2 is the common factor. So when we remove this common factor 2, we are left with the number 1 with both the symbols. Since the subscript 1 is not to be written, so the formula for calcium carbonate would be CaCO3. Clear? Understand? Means the common factor between the number corresponding to the charges must be ignored. Okay, here 2 is common, so we ignore that common factor. Clear? Okay, so it is enough for today's lecture. So thank you and have a nice day.